Hello ENCON managers, greetings from Raghavan, ORPAC Group of Companies, Pune. Specialist from air conditioning refrigeration field with 38 plus years experience, having worked in two American corporate companies in India for a long time. Currently I am manufacturing hot water heat pumps and industrial process chillers. I hope you found my first video posted last fortnight a little more useful and interesting for you. Through this 8-part series, I plan to give you as much practical aspect information as possible on heat pumps so that it triggers more thoughts in you, ideas, and help you to take an informed decision making to be able to implement heat pump projects if applicable in your work area. In the first episode, we discussed what is a heat pump, how does it work, why the COP is more, etc. In this second part, we are going to discuss about the types of heat pumps so that in the next episode when we get into the details, you are ready to understand the whole thing about heat pump. So if you come to the classification of heat pump, taking only heat pump, this classification I am putting from whatever I have seen, this is pertaining only to the hot water heat pump. Okay, it doesn't cover the entire hydronic systems, not the chilled water, not the very high temperature, etc. Talking only about the heat pump classification, I would classify them generally based on two ways. The first way is based on the temperature band. The second is based on what is the source and what is the sink being used by the heat pump. Let us first talk about the type of heat pumps based on the temperature it is delivering. So basically there are 4 types of heat pumps which are in the small capacity range, which could be applied in your industries. First is a sort of lukewarm temperature heat pumps, maybe about 26 degrees centigrade to 30 degrees centigrade output temperature. You may ask, this is a normal ambient water temperature, why at all you require a heat pump? Okay, some of the applications, for example, commercial application like swimming pool. The towns and cities which are away from the coast, maybe Bangalore, Pune, Hyderabad, Nagpur, Delhi, etc., many such towns, the swimming pools during winter time may become very cold, like 10 degrees, 12 degrees. So it is not conducive for swimming. So this could be one application where the lukewarm 26 to 30 degrees centigrade hot water heat pumps are required. The second type of heat pump, which is slightly one level higher than the lukewarm temperature, is what I would call a hygiene heat pump, which are used in again commercial applications, for example bathrooms, for our bathing purpose, for example. Generally here the heat pumps deliver about 50 to 60 degrees centigrade hot water output. Though many health institutes recommend a hot water temperature for bathing to be in the range of 38 to 41, 42, not more than that, because it scalds our skin. Still the heat pumps generate up to 60 degrees centigrade because the way the heat pump is deployed in the site with a lot of incoming cold water mixing with the hot water storage, so it drops the overall resultant temperature. So this is the reason we go up to 60 degrees centigrade output, though actually we may not bathe at 60 degree water, we may use slightly milder hot water. Now let us move to the industrial application, the last two types. One is what generally I call as the typical industrial application heat pumps, which generate about 70 degrees centigrade to 80 degrees centigrade water temperature. Almost many applications that you could be having in your process shop will fall under this category. For example, a degreasing solution, you want to maintain about 45 degrees to 60 degrees centigrade, de-rusting tank. There could be many solvent machines you will be using, ultrasonic cleaning or many other type of cleaning machines, where the auto components or any other component are being washed to remove the grease, oil, etc. So in all these applications, you will be requiring about 55 to 60 degrees centigrade hot water. If you could use this degreasing solution directly in the heat pump, or you could directly apply hot water for cleaning the parts, about 60 degrees should be good enough. But usually what happens is, we don't use hot water alone in these tanks. You may be mixing a degreasing compound along with the water. So that may or may not be conducive to the material used in the construction of the heat pumps. So many a times we see practically we using a secondary PHE, plate type heat exchangers, using different secondary pump, etc. So on one side the degreasing solution or your process solution will flow, and on the other side the hot water flows. Though you may require only 60 degrees centigrade, unless the hot water is of higher temperature, you won't be able to get 60 or 65 what you need in the tank. This is the reason we go up to 70 degrees or 80 degrees output hot water temperature from the heat pump. Of course, all the manufacturers give a controller which are user settable. If at all you require any lower temperature, you will be able to slightly lower the set point. The latest addition in the heat pump category using refrigeration equipment is the 120 degree centigrade heat pump. Though all of you are familiar, you might have seen 180 degrees, 240 degrees and all kind of temperatures using high pressure boilers or thermic fluid heating systems, heat recovery systems, assuming you have an aluminum foundry or something, from the flue gas you are recovering heat. You might have seen all higher temperatures. What I am talking today in this episode is whatever we are able to generate using a simple refrigeration system, smaller capacity range. Let us say less than 100 kilowatt capacity, less than 50 kilowatt capacity. So the 120 degree centigrade heat pump is a recent addition with the development of compressor technology, availability of refrigerant, which is suitable for use in this particular application. So using this 120 degree centigrade heat pump, even many CIP process where you require 95 degree centigrade hot water, for example, hygiene cleaning of food and beverage tank, could be a wine tank, could be a beverage tank, could be a milk tank, anything that comes to your mind. So in many F&B applications for CIP, people require 95 degree centigrade hot water. So the 120 degree centigrade heat pump fits here. So out of this 4 category of heat pumps, based on the temperature range it delivers, what will be of interest to you guys, ENCON managers, will be the standard 80 degree centigrade and the high temperature 120 degree centigrade. Now let us move to the type of heat pumps based on the heat source and the heat sink. So what does that mean? Let us have a quick discussion on that. So I would put them in 5 different categories. First is a standalone air to water heat pump. You want to keep the heat pump outside your factory compound walls, okay, not within the shop floor, just outside the shop floor. It's called a standalone heat pump. So it is using atmospheric ambient air, and so that is the source. It is transferring the heat, building up, transferring to the water which is circulating, which you are using in your process. So this is called a air to water. Air is the source, we are transferring the heat to the water, which is the sink. Now assuming you are air conditioning your assembly hall, okay, using the heat pump's available cooling capacity, and you are generating hot water. What type of heat pump it will be? Air to water, because the source is the shop floor air where you are cooling the air, right? So that is the source and we are transferring into the water. So again, air to water. The second type of heat pump is water to water. Assuming you have a lake, a pond, because many industries look so green nowadays with a lot of landscaping done, etc. So some industries do have small ponds or lakes or any other water bodies available readily. You are using the heat of that water body, transferring it to this hot water where you want to generate heat. So again, water to water. You want to use the heat available from a cooling tower water, water to water. You are having a chiller plant and you want to take the heat from the chilling system and generate hot water, water to water. So we discussed about air to water heat pump, water to water heat pump. 2 more types are assuming your output required is not hot water but hot air. So what could be the application for you ENCON managers with respect to hot air? For example, many auto components, after machining, cleaning, etc., after a degreasing wash, it will be still dripping with those water particles. So I have seen in many factories people having ovens where they take the oven temperature up to 90 degrees, 100 degrees, 110 degrees, keep the components hanging with large blowers circulating air to dry them up so that it is in a shape for dispatch. Now here instead of hot water we require hot air. So how do we generate hot air? Same thing. From source you are transferring heat to the sink. So either from ambient air we can transfer it to the hot air, or from water we can transfer to air. So it is called air to air heat pump or water to air heat pump. So we discussed air to water, water to water, air to air, water to air, 4 types. The fifth one I call is hybrid. What is this hybrid heat pump? Many ENCON managers discuss with me. We use, for example, a chiller system or HVAC system during summer 2 months or 3 months. In Pune, generally March to June is the summer season. Rest of the season they say we keep it off, we shut down the plant. So what they say is, if your heat pump can help us to reduce the chilling plant load, HVAC load during summer with whatever capacity it is able to give, automatically it benefits us in lowering even the HVAC plant energy consumption. But balance 9 months with no chilled water available, they say you have to use the ambient air. So during summer it becomes a water to water heat pump. The rest of the 9 months it has to switch to another mode, air to water. This is possible when we customize the heat pump for such a specific customized application. It's very much possible, though may not be available as a standard product. It is a customized product. So this is how I normally classify the heat pumps. The next episode we are going to go into the details of a air to water heat pump, see the typical running parameters, understand the energy consumption, etc. Before we close this episode, let me remind you, if at all you are finding this useful, do subscribe to motivate me to continue on this particular assignment, and do share this particular link with your friends who are also ENCON managers in other factories. And if you are a member of any group working on energy conservation, do share this. And if you have any suggestions, feedback, questions for me, do post them here. So we will be able to deliberate on them in the subsequent episodes. With that, thank you very much, and we will catch up again next fortnight. Thank you.